about to leave, already packing. Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free with me. Let's go, let's be free with Not looking back, eyes on the freeway, Bonnie and Clyde, a classic cliche. We're on the run, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free.
Good evening and welcome to tonight's live stream. Tonight we are revising Desert Systems and Landscapes for AQA A-Level Geography. It is an optional topic, so if you don't do it, you might not want to stay tuned. We can see we've got about 10 of you at the moment, so hopefully we'll have a few more of you joining. We do realise, though, don't we, Fiona, that this is a less popular option. We had lots and lots of students with us for COAST a couple of weeks ago, so we were not expecting that many of you this evening. As usual, we're going to have 6 activities that will alternate between myself and Fiona. And we would like you to pop your answers into the chats and we will have a look at what you are contributing that way. If you've got any questions about any of the content that you're not sure about, then pop those into the chat as well and we will try and answer those for you if we can. Little bit of housekeeping as usual from me. This will last about half an hour, maybe 40 minutes. We do these every week at 6 o'clock on a Wednesday. So if you've missed this, I think this is our 7th one, isn't it, Fiona? I think. If you've missed any before, then please have a look at the previous ones on playback. We've done global governance, global systems, we've done water cycles, carbon cycles, we've done changing places, and we've done coasts. So we've done quite a lot so far. We are here generally every week, but next week we're not here because we are on the cinema grade booster tour. So Fiona and I will be back in 2 weeks' time to do population and environment. So just a heads up that we are not here next week. If you want to know when the sessions are, then if you have a look on our Instagram page, there is a timetable of all of the sessions there. And also on our Instagram page, every single morning we publish a revision question. Covering every single topic of the spec. So from here until your very final exam. So even those really obscure topics that only about 3 schools in the country do, there are still some questions for you. So we are going to get started quite swiftly tonight. And I'm going to hand over to Fiona, who is on altered vowels, which is always a good one. Right, Fiona, off we go.
Thank you very much. Okay, so if you haven't played along with this one before, what we have is we have some of the key terms within the deserts topic, but the vowels have been changed. So it looks like a bit of a different word. All the other letters, though, are in the correct order. Let's take a look at the first one. Oh, this one is a very long one. So what have we got here?
I'm really sorry about this one, Fiona.
Yeah, it's a very long one. Got to get my best voice on for this one. So
Off
we've
you
got
go.
P Tantail, A Vit Pet Trin Spa Eation. Teation.
Not bad.
We got to love these ones. So what kind of term do we think this might be associated with the deserts? It is a tricky one. Let's see, we have some answers coming through. We love it when you take part. We love it when you put those answers into the chat to see what we might have here. But this is definitely a tricky one to get us started.
Should we give them another couple of seconds and then reveal this one?
Yeah, a couple of seconds just to see whether anyone thinks they might know what this one is. I always have a play with these first to try and work it out. Oh, brilliant. There we go. We have got Ollie there. Tom, it looks like you got half of the word there. Good. So we've got potential evapotranspiration. So a very, very long term there. And here we're thinking about that amount of water which would evaporate or transpire from plants if water was unlimited. Obviously, in a desert, it being very, very hot, the potential evapotranspiration rates there are going to be very, very high. Okay, let's take a look at the second one. I tell you what, Vicky, you give me some cracking things to try and say with these.
Yeah, I work hard to make these as hard as possible.
We've got much and also whatho wrong. And I feel like you can kind of guess what that one is from what I am saying there. So what do we think this one is? Again, another 2 words to put together into a key term. Brilliant. It looks like the best chocolate. That's a great name there. Has got that one. It is indeed mechanical weathering. Now, I love mechanical weathering. I always talk about Shrek and him talking about ogres being like layers. Rocks have those layers as well. We talk about things like that onion skin weathering, thermal expansion there. And this is due to that breakdown, the rocks breaking down due to those extreme temperature fluctuations. It's obviously very, very hot during the day in the deserts, but very cold at night because there isn't that cloud cover there to keep in that heat. So we've got that mechanical weathering. Okay, let's take a look at the next one. Okay, another nice one to say here. Ualun Prakasas. I feel like I'm saying like a Harry Potter type spell with some of these words. So let's see who.
I think the right version of this is actually a really nice word to say as well.
Oh, yes, definitely.
Not very easy to spell, though.
No. Lots of vowels in there. Let's see who's going to be the first one to get this one. Ah, brilliant. We've got the breaded man there who has got in there first, followed by Ollie. And it is those aeolian processes, those wind-driven processes like saltation, where we have those grains of sand being bounced along, creep when they roll along, and suspension where dust is carried around in the air. So those aeolian processes there. Brilliant. Let's have a look at what is next. Underuak Druangugu.
I think this one is quite tricky.
Yeah, definitely. Druangugu. Lots and lots of vowels in there again. Tell you what, in the deserts topic, I feel like they have some of the best vocabulary in there. Got some really, really interesting key terms in there to learn.
Oh, I think this one might have stumped everyone. Just going to give them
Me
a couple
too.
more seconds before I reveal. Right, let's reveal this one.
Yeah, this one is a tough one, isn't it? And it's those endorheic drainage. So when we're thinking about endorheic here, we're thinking about those closed drainage systems. So where water doesn't have that outflow to rivers or the ocean. So it's all within one system. There is no kind of output there. Often that water is very salty, very saline. If you've looked at kind of the different landforms in the desert, you know that salt is a pretty big player there within the desert. Okay, that one was a tough one. Did anyone get it in the end? No, that
No.
one was a tough one. And you know what? When I looked at that one for the first time, I was a bit stumped as well.
Well, I couldn't
Okay.
remember what it was earlier when I checked through the PowerPoint, to be fair. It's probably worth pointing out as well that most of the water here gets evaporated due to the hot,
Yes,
dry desert climate as well, because obviously, like Fiona said, it is stuck in one system.
absolutely. I think we have one more.
Yeah, hopefully slightly easier
A
one.
ensalitian. Ensalitian. Let's see who gets this one first. It's nice that even though there's only a few of you, kind of 10, 11 people watching this live at the moment, that lots of you are still taking part within putting the answers into the chat. Let's see whether anybody is getting this one. Ensalitian.
Yeah, it stumped them, hasn't it, again?
It
Oh, hang
has.
on. No, we've
Oh,
got
there we
somebody.
go. Sophia Sanchez. It is indeed. Let's take a look. So that insolation, the amount of solar radiation that is reaching a given area. So obviously the deserts there are nice kind of expanses that are nice and bright. So deserts receive some of the highest levels of solar radiation on Earth. So it is another really important term for us to have within this topic. Well done, everybody. There were some really tough ones in there,
Yeah.
but you are off to a flying start. Vicki, over to you.
Okay, so we're going to do a categorise activity now. You're going to have 1 minute on the timer, and you need to pop those 8 landforms that are either made by or caused by water or caused by wind into the correct column. So in the chat box, if you can put a W for water and an A for aeolian landforms, and then obviously the numbers after those. So I'll set the timer off now. You've got some quite dramatic music to work these out to. Okay, so let's reveal the answers. Well done if you had a go at these and if you got them correct. Okay, let's have a look. So we start with our aeolian landforms first, our ones that are caused by wind. We've got deflation hollows. So these are depressions in desert surfaces formed when wind removes loose sand and fine particles. So over time, this continuous wind erosion will lower the ground level and it will create shady basins or hollows, where that word comes from. Some deflation hollows can become very large, and some even are so large that they might reach down as far as the water table. We've then got desert pavements. So these are flat, like the name suggests. They're stony surfaces found in the desert. And this is where the ground is covered by closely packed pebbles and rocks. And these form when the wind removes finer sand or dust, leaving large stones behind on that surface. And over time, these stones protect the ground underneath. And that means the erosion will slow down and may even stop. Then we've got quite a good term here, yardang. So these are interesting. These are long, narrow ridges of rock, and these are formed by wind erosion, like we've already said, where these happen when strong winds carry sand, and this wears away the softer rock, and that leaves great big streamlined ridges, and these run parallel to the wind direction. So over time, this will create distinct elongated landforms, and they've got like big grooves and troughs in between them that separate these yardangs. And then our last one for aeolian processes are seaf dunes or scythe dunes, and these are long, narrow sand dunes. And they form in the desert. So they're really like the sort of ones that you picture when you sort of picture what the desert looks like in your head. And this is where winds blow from two different directions, and the alternating wind shape that dune into a really sharp ridge, and that runs parallel to the prevailing wind direction. And they can stretch for miles and miles, and they're sometimes also known as longitudinal dunes as well because of the way they stretch out. So if we then have a look at the ones that are caused by water, we've got wadis to begin with. So these are dry river valleys or channels that we find in deserts, and they usually remain dry for most of the year. But if there is an episode of heavy rainfall that you do occasionally get in the desert, they will fill with water very quickly, and they flow rapidly as well when they do fill with water. So flash floods can actually occur in these valleys because the desert ground absorbs the water really, really slowly. So infiltration is a very slow process here. Right, we've also got Bahadas here, and I'm not really sure that I've even pronounced that correctly, but these are large, gently sloping plains, and they form when lots of alluvial fans join together at the base of desert mountains. And they are created by sediment that gets deposited by streams. And again, these are caused when these happen when you get rainfall events that are really intense. And obviously, these are rare, but they do happen. And over time, these emerging fans kind of work together to form a broad, continuous slope of sand, gravel, and rock, and that's what these landforms are. We've got pediments here, which are broad, gently sloping rock surfaces found at the base of mountains in these desert regions. So remember, we do get lots of mountains in desert regions, particularly places like Sahara has got big mountain systems running through. And they form through erosion by running water, and they also form by weathering that gradually wears down the mountain front. And over time, this creates smooth, low-angle surfaces which are covered in a thin layer of sediments. And then we have got Inselberg, which is one of my favourite key terms in deserts. And these are isolated hills or mountains, and they rise really steeply from that sort of flat desert plain. So they're quite spectacular. And they form when the soft rock that is surrounding is eroded away, and it leaves behind a really resistant rock mass. And they appear quite often as dome shapes, or they're sometimes steep-sided rocky outcrops in desert landscapes. So again, really interesting features. Right, I'm going to hand over to Fiona now for the big reveal.
Okay, so I'm going to give you a series of clues, and the clues all lead to one key term within the deserts unit. So as soon as you think you've worked out what it is that I am talking about, if you put your answer into the chat, and can you work them out before I have revealed what the answer is? Let's take a look at the first one. Okay, so this hydrological feature reflects closed drainage conditions typical of environments with high evaporation rates. Water is lost from this system mainly through evaporation, often leading to increasing salinity over time. It is most commonly found in arid and semi-arid regions where rivers are short, intermittent, and rarely reach the sea. Examples include salt pans, playas, and inland lakes found in deserts such as the Sahara or Central Asia. And it is a water source in a desert where rivers drain into inland basins rather than flowing to the ocean. And we've had a couple of people put some answers in. So these are, so a few of you have put players in there, which are related to what I am going to give you as the answer in a second. But there is a term, and it's a term that I've used already this evening that might give you another clue. Let's take a look and see if somebody gets it. It is an endorheic water source. So like I said with these ones before, These are those landlocked drainage basins. So the water doesn't go anywhere. It doesn't flow out to the sea like we would expect it to in a normal river system. So these are very saline due to those high evaporation and evapotranspiration rates. And they're like, they're not what we would expect of a water system. We are used to water systems flowing out to the sea, so they are quite a strange occurrence to us as geographers, but they are found in, or they're most commonly found in those arid and semi-arid regions which you have been studying. So well done there. We've got a couple of people who got it in the end. Ollie and Tom Kenny, well done. Okay, second one. Let's take a look. So this pair of processes, so we're thinking about two things here, reflects mechanical weathering driven by extreme diurnal temperature variation. They involve physical breakdown without chemical alteration of rock material. The repeated heating and cooling causes stresses within rock surfaces, leading to fragmentation over time. One process causes rocks to break down into angular blocks, whilst the other produces sand-sized particles. I think that might give you a bit of a clue as to what I'm going to say. Or we are getting some of those answers in there. And they're types of physical weathering in hot deserts where rocks break into blocks or grains due to temperature changes. So we're definitely along the right lines there. The best chocolate. Let's take a look at that answer. So it is block and granular disintegration. So both of them kind of it does what it says on the tin, really. So with block disintegration, we have rocks like limestone, for example, rocks that are well jointed. The breakdown because of that heating and cooling breaks the rocks down into blocks. Whereas granular disintegration, again, if you think about granules, I'm thinking about teeny tiny little crystalline forms. So this usually happens with crystalline rocks, something like granite perhaps, and they break down or they crumble down into those individual grains. So if you look at granite, it looks like it's lots of little bits stuck together. That is where that granular disintegration will break those down into those kind of individual little crystals of rock there. So well done if you got that one. Let's take a look at the next one. Okay, so these landforms are shaped by aeolian processes operating in environments with limited vegetation cover. They develop through abrasion caused by particles transported close to the ground. Their surfaces are often smooth, faceted, or polished as a result of persistent wind action. I think some of you may get it from that clue alone. They are commonly found in arid landscapes where sand-laden winds are frequent. And the final clue is they are rocks shaped and smoothed by wind erosion in hot desert environments. So we're thinking about the rocks here. Ah, brilliant. There we go. The best chocolate, Ollie and Tom Kenny there as well. They are indeed ventifacts. So I love the look of ventifacts. They are obviously nice and smooth. Some of them have more than one smooth side, and we can have a little cross-curricular here with some German vocabulary as well. So ventifacts are categorised by the number of faces or facets that they have. So we can call one that has just one smooth surface something called an Einkanter, or if they have two smooth surfaces, they are a Zweikanter, or three would be a Dreikanter. So some of them look like they've been really polished, like it's almost a human action that's happened, but it's not. It is that wind action there smoothing across the front of those rocks. There are some, if you Google different ventifacts, there are some amazing looking ones out there. Okay, is it just three that I've got the big reveal? It is. Vicky,
it is just three.
To you.
Okay, so we're going to have a look at a bubble quiz now. So this is a bit of a variation of a multiple choice quiz in that you've got a question and then you've got some answers to pick that are correct, but they can be maybe none correct, they can be all correct. There might be 1, 2, 3 correct. So let's have a look at our first one. Which characteristics are typical of a hot desert climate? a high diurnal temperature range. So this is the difference between that daytime temperature and the nighttime temperature. High potential evapotranspiration, we met that term earlier. Low annual precipitation and frequent chemical weathering. So if you just pop down the letters that you think are correct in the chat, and we'll just give you a minute to get your ideas down there. So A, B, C and D, which ones do you think are correct? Just give you a moment to pop your ideas in. Okay, so we've got A, B and C coming through. Let's see whether you are correct. Yep, it is. So high diurnal temperature range, high potential evapotranspiration, and low annual precipitation. So frequent chemical weathering is not particularly a typical characteristic. Right, number 2. Which of these processes are the most important in rock breakdown in hot deserts? So we've got block disintegration, freeze-thaw weathering, chemical weathering, and granular disintegration. So again, pop your letters in the chat, the ones that you think are correct. So these are the most important processes in the breakdown of rocks in hot deserts. So just give you a moment. So we've got A and D coming through at the moment. A, B and D coming through. Let's see whether you are right. So although freeze-thaw weathering is a process, it's not one of the most important ones. So block and granular disintegration, which Fiona just spoke to you about, are our most important ones there. Right, number 3. Which of these statements about water in desert systems are correct? So rivers are usually perennial and continuous. Flash floods can occur despite low annual rainfall. Water plays a key role in erosion during infrequent rainfall events, and all desert drainage systems are exoric, which is spelled incorrectly. So if we have a look there should be an H after the R. So I apologise for that. It's speedy typing. I didn't notice that before I popped it on. So which ones of these are correct? So exoric should have an H just after that R. So again, pop those into the chat. We will see if you are correct. Okay. Okay, so got some answers coming through. Let's have a look and see if you are correct. It is B and C. Well done, Ollie. You came through with that first. The best chocolate following shortly. So flash floods can occur despite the low annual rainfall. We talked about that right at the beginning. And water does play a key role in erosion during those infrequent rainfall events. So we covered that in our categorised activity. Right, number 4. Which of these landforms are mainly shaped by wind erosion in deserts? So again, we've covered this already. We've got the Scythe dunes, Inselbergs, Ventifacts and Yardangs. So which ones of those are mainly shaped by wind? So they are aeolian landforms. Again, I'll just give you a moment on those ones. Okay, let's have a look. We've got C and D coming through. C and D again. Well done, best chocolate. Well done, Ollie. Let's see whether you are correct. No, we are missing Scythe dunes, so they should be there as well. Okay, next one. Which of these factors increase human vulnerability in desert environments? So we've got the over-abstraction of groundwater, high and reliable rainfall, climate change increasing aridity, and population growth, which is rapid. What do we think? So it's our last bubble quiz. Okay, so we've got a couple of answers coming through already. Okay, so let's see whether you are correct with A, C, and D. Well done, Bus Chocolate. Well done. Oh, Ollie, you might want to have a quick look at yours again. It is A, C, and D. So over abstraction of the groundwater, climate change, increasing aridity, and rapid population growth. So high and reliable rainfall not playing a part there. Right, Fiona, back over to you.
Okay, so this is another 30-second challenge. So I'm going to put the question up on the screen and you can put the answers, or at least a short version of the answers, into the chat. So first of all then, which factors affect aridity in hot deserts? Let's have a look. Let's go. 30 seconds. Seconds always goes so quickly on these. So let's see what kind of things you think in the chat are factors which affect aridity. Let's see whether you got these. So the first one is probably the most obvious one to us, which is that low precipitation. So if we think about where the deserts are and we think about that the atmospheric circulation around the planet, deserts are caused by that descending air. So where we've got high pressure, and if you have high pressure, you're going to have low precipitation. And then we've got those high temperatures where the temperature is high. Any kind of moisture that's on the surface is going to be evaporated. And obviously any plants that we might have, there might be transpiration as well. So we had that term earlier, that potential evapotranspiration. Then the final one there is cold ocean currents. So they reduce evaporation and cloud formation. Again, we need clouds for the rain to form, which limits rainfall. And we've got an example there. So we've got the Humboldt current. So if you're unsure what the Humboldt current is, this is an ocean current that flows along the western coast of South America. It is a cold, low salinity ocean current as well, named after a geographer, Humboldt, who spent lots and lots of time in South and Latin America. And some of you, I think, did get that one on there, didn't you? About the precipitation rates, cold ocean currents. Brilliant. Well done. So if you can get those ones into an answer in your exams, you will be doing absolutely fantastically. Let's take a look at the next one. Okay, so different topic this time. Which factors increase the risk of desertification? Oh. 10 seconds left. 5 seconds left. Okay, so what kind of things are going to increase the risk of desertification? Let's take a look. Okay, so we've got things like overgrazing. So where there might be too many animals for the vegetation which is there. So they're removing all that vegetation cover. We know that vegetation cover helps to hold onto the soil that is there. So if it's been removed, that's going to increase soil erosion, reduce soil fertility. If we look at a place like the Sahel, for example, overgrazing is a definite cause there of desertification. We've also got deforestation. So again, the same kind of things are happening there. We are removing that vegetation, removing the roots that are holding onto that soil. It's going to expose the soil to erosion. It's going to reduce evapotranspiration and soil moisture. And again, we're going to end up with soil which is not very fertile, not able to grow things. And we end up with that spread of those deserts. And then finally there, we've got climate change and prolonged drought. So again, we reduce that precipitation. We can see there's a pattern happening here, increase in evaporation, and that's stressing that fragile dryland ecosystem. So again, we think about places like the Sahel. We've got that real risk there that Sahara Desert is going to continue to spread. Obviously, there are things that are happening to try and reduce that. We can think about solutions such as the Great Green Wall, for example. But we know that these things, overgrazing, deforestation, climate change, I think some of you have put some other things on here as well, land use change as well, where, urbanization is occurring, more people are moving to areas. So lots of different things that are going to increase that risk of desertification. Let's take a look at the next one. So thinking about what we've just said, our next question is, how does desertification impact ecosystems, landscapes, and populations? 30 seconds, go. You're at the halfway point. Okay, let's take a look. So we're going to have some quite close links to what we've just said previously. So in terms of ecosystems, if there's a loss of vegetation and biodiversity, we're going to reduce ecosystem resilience and productivity. Plants aren't going to be able to grow as well. The soil is going to become more infertile, which is going to lead to more plants not growing. Any animals that are reliant on those plants to grow are going to lose a food source there. In terms of the landscapes, we've got increased soil erosion and land degradation, kind of what we've just said previously as well, leading to more bare infertile surfaces. And then in terms of the population, we're going to have reduced food and water security, particularly if things aren't growing, leaking back to that ecosystems point there, which could cause poverty, migration, and increased vulnerability. Some of you have put some excellent things into the chat as well about sandstorms due to that loose sediment. Excellent, because if there's no roots holding onto those holding onto the sand and the soil anymore, obviously that makes that very easy to pick up by the wind, causing those sandstorms. We get brilliant lower yields for farmers. People may migrate. Brilliant. Looks like you have really nailed desertification there. Well done, everybody. I think it's back over to you, isn't it, Vicky?
Yeah, so we're just going to finish off with 8 true or false statements. So nice, easy last task. You just need to put a T or an F in the chat box for the ones that you think are true and the ones that you think are false. So our first one is desert systems are open systems with inputs of energy and limited inputs of water. Is that true or false? So a nice, easy one to start. So just give you a moment to get your answers into the chat. Okay, let's see whether you are correct. Yeah, this one is true. So a nice easy one. They are open systems, inputs of energy, but obviously limited inputs of water there. So well done. Those answers are just coming in now. Mechanical weathering is more dominant than chemical weathering in hot desert environments. Is this true or false? So again, just give you a moment. I've still got some truths coming through from the last one, I think. We've had some really good inputs tonight from 3 people in particular. So Ollie, Tom, and the best chocolate, you have given us some great answers. So it's no wonder you were first to answer these ones. Yeah, so we've got some truths coming through again from the same 3. Yeah, it is true. So we've already talked about this today, haven't we? Talked about it earlier about the particularly exfoliation, with the fact that you've got these really big temperature extremes. So the rocks heat up, they then cool down, and they expand and they crack and they come off in layers. So that's really important. Whereas chemical weathering doesn't play a major role in the desert. Salt weathering is another example of mechanical weathering, which is important. Right, number 3, flash flooding is rare in deserts because annual rainfall totals are very low. I'm going to give you a moment here to answer this one. So we've got a false coming through. We've got Ollie, false, Tom, false, best chocolate, all false. Yeah, that is correct. So it doesn't happen that often, but it isn't completely rare. So we've already talked about how deserts often experience short, really intense bursts of rainfall rather than steady rain. And because the ground is really dry, it's really hard, and that means it can't absorb that water quickly, so infiltration doesn't happen. And that leads to rapid surface runoff, which then leads to those sudden and powerful flash floods in dry water channels, such as the wadis that we talked about earlier. Right, next one. So this is number 4. Erosion by wind is most effective close to the ground where sand grains cause abrasion. Is this true or false? So we think about abrasion, it's sort of the erosion that's almost like a sandpaper effect, isn't it? So is this going to be true, this statement? Erosion by wind is most effective close to the ground where sand grains cause abrasion. I'll just give you a moment to get your answers into the chat with this one. Yeah, so we've got some trues coming through. Well done. Yeah, same 3 and all correct again. So that one is true. Rock pedestals are formed primarily by wind erosion, acting more intensely near the surface. Is this true or false? So this is number 5. So rock pedestals are formed primarily by wind erosion, acting more intensely near the surface. True or false? Okay, so Tom's in there first with this one with a true. Yeah, best chocolate, well done. Let's see whether Ollie's got something in. Okay, let's see whether you are correct. Yeah, well done. All 3 of you are going for true. Excellent. Right, this is number 6. Deserts are shaped mainly by wind processes rather than water. True or false? So again, I'll give you a few moments to get your answers into the chat. Okay, what do we think? We've got so we've got Tom coming through with false. Ooh, we've got Ollie with false, but we've got the best chocolate with true. Let's see who is correct. This one is false. So it's false because deserts because water plays a major role in shaping those desert landscapes, particularly through the flash flooding that we've already talked about and that occasional heavy rainfall that you get. And when this happens, it causes severe erosion, but also transportation, and then as a result of that, deposition of sediment. And that will form those features such as wadis, the alluvial fans that we've mentioned earlier, the bahadas. Wind is important, but water is the dominant force shaping desert landscapes here. Right, next one. So this is 7. All deserts are hot and experience consistently high temperatures throughout the year. Is this true or false? So hopefully this is quite an easy one. So just give you a moment just to get your answer in. Let's see what we're coming up with. So all deserts are hot and experience consistently high temperatures throughout the year. Yeah, so we've got an agreement all coming through here with false on this one. And you are obviously correct. So we know that all deserts are not all deserts are hot. Some are actually really cold. So Antarctica, for example, is officially the world's largest desert. And desert climates are defined by low rainfall, remember, not the actual temperature. So as well as Antarctica, we've got some cold deserts in Central Asia as well. So many temperatures also experience that massive temperature change as well. So although they might be really hot, they can have really cold nights or they might have really cold winters. Okay, our last one is low rainfall in deserts means rivers play no role in shaping desert landscapes. Is that true or false? So again, I'm just going to give you a few moments to get your answers into the chat. Okay, so we've got Best Chocolate coming through first with false. Tom's gone for false. And I think Ollie's also in there with a false. Let's see if you are correct. Yeah, all three of you. Well done. All correct again. It is false. So rivers and streams can still shape those desert landscapes during rare but intense rainfall events. We talked about flash floods already. They can erode rock, they can transport that sediment, and they can deposit material, and that forms those features that we've already mentioned earlier. So they might not flow consistently in the desert, but they do still play an important geomorphic role in shaping those desert landscapes. Right, well done. Some really great answers there from a few of you today. Considering we haven't had high numbers watching, we've still had some really good answers. Hopefully it's been a useful session to you. And if you haven't seen some of our other sessions, then please go back on our YouTube channel and have a look at the previous 6 sessions that we have done. And just to remind you again that Fiona and I will be back in 2 weeks' time to do population and the environment. So if that is one of your option subjects, then please join us for that. And again, just to remind you that we've got plenty of revision materials on our website, but we've also got those daily revision questions on our not our YouTube channel, because that's where we are now, on our Instagram feed. So just for me to say thank you for the great answers that you've put in. It's been really good, always really nice revising with you, and particularly when you are joining in as well. It makes our job a little bit easier, doesn't it, Fiona? So Fiona and I will, I think, say good night now and hope you have a good week, and we'll see you in a couple of weeks' time. Okay, good night.
Bye, everybody. Bye.